Okay, we are already done with the topic of compact bone. Now it's time for spongy bone. I know it's cringy, but I don't care. Anyway, spongy bone. First things first, where is spongy bone found? It's found in flat bones and the epiphysis of long bones. Let's look at the structure of a long bone. So this is what a long bone looks like. It's long, and then at the two ends of the long bone there are knob-like structures, and these knob-like structures are known as epiphysis. In the middle there's a shaft, and this shaft is known as diaphysis. Inside diaphysis there's yellow bone marrow, which fills up the bone marrow cavity of diaphysis, and inside epiphysis there's a red bone marrow that fills up the space of bone marrow cavity in epiphysis. Okay, in the previous lecture we have already considered, or we have already learned about diaphysis, and we now know that diaphysis, the bone that makes up the diaphysis region of long bone, is none other than compact bone. However, in epiphysis you find spongy bone. That's what we are going to deal with today. Spongy bone and compact bone, in terms of things found in them, there's no difference. What do I mean by that? Spongy bone contains cells and matrix, same as the cells and matrix found in compact bone. So what are the cells and matrix found in spongy bone? Cells present in spongy bone are: number 1, osteoblast cells that give rise to osteocytes or bone cells, osteocytes, which are the star-shaped bone cells, and osteoclast, which are the cells that eat the old osteocytes so that it gets replaced by newer osteocytes. And for matrix is made up of inorganic substance and organic substance. As inorganic substance, there's your salts of calcium, which include calcium phosphate and calcium carbonate. Both these salts, that is calcium phosphate and calcium carbonate, together makes hydroxyapatite, which provides hardness to your bone. And then there's your organic part, which includes the matrix protein, osin, and the fibers found in the bone. Okay, now these stuff are arranged differently than compact bone. That's the difference between spongy and compact bone. The things found in both of them, that is the cells and matrix, is same. However, the way these cells and matrix are arranged is different. Let me show you a diagram of spongy bone. So spongy bone contains highly branched structures, and these highly branched structures are known as trabeculae. In between these branches or trabeculae, there's empty spaces or the bone marrow cavity, and these empty spaces are filled with red bone marrow. In spongy bone, Haversian system is not found. So Haversian system, I've already mentioned in the previous video, is a characteristic feature of mammalian compact bone. So Haversian system is only found in compact bone. It is not found in spongy bone. But even in compact bone, it's only found in mammalian compact bone. Okay, why has this bone been given the name spongy bone? Because due to the presence of empty spaces in between the branches or in between the trabeculae, it gives off a sponge-like appearance. That's why it has been given the name spongy bone. So I guess that is more than enough for spongy bone. Now it's time for treatment of bone. That is what happens to your bone when it is treated with different chemicals or different processes. Okay, we know that a human bone contains organic matter and inorganic matter. As inorganic matter, there are your inorganic salts, which includes hydroxyapatite, and this provides hardness to your bone. And as organic matter, there are organic substances such as protein, osin, and fibers, and they provide tensile strength. Okay, so there's inorganic salts that provide hardness, there's organic substances that provide tensile strength. Okay, first treatment with hydrochloric acid or HCl. When you treat a bone with HCl, what happens? So bone has two portions, inorganic portion and organic portion. When the bone is treated with HCl, the inorganic portion dissolves, that is the salts of calcium dissolves. So the process is known as decalcification, because the salts of calcium has been removed, and the bone is known as decalcified bone because the salts of calcium have been removed. Such bone is flexible. The reason for this, since the salts of calcium, that is hydroxyapatite, has been removed, and the reason bone is hard is due to hydroxyapatite, it loses its hardness, and when bone loses its hardness, it becomes flexible, so you can bend it. Then there's second, treatment with KOH. Upon treating bone with a solution of potassium hydroxide, there's no effect. Thirdly, treatment of heat. So when a bone is heated, there's two parts, right? Inorganic part and organic part. Here, the organic part dissolves, that is the protein, your bone marrow, the fibers covering the bone, all of the organic parts, they dissolve and get removed, and only inorganic part remains. As a result, the bone is brittle, that is, it is highly susceptible to fracture or can break easily. Okay, so when you are young, in your bone, the percentage of organic matter is high. That's why the bone is tough. As you get older, right? As you get older, the inorganic matter, the percentage of inorganic matter increases and bone becomes brittle. How? I've already mentioned in the treatment of heat. When you treat a bone with heat, the organic portion gets removed and what's left is inorganic portion, and due to the presence of high percentage of inorganic portion, the bone is brittle. Similarly, in adult, naturally, the percentage of inorganic substance increases or salts increases and the bone becomes brittle. That is why the bone is more susceptible to fracture as you get older. Okay, that's it for spongy bone and decalcification. Treatment of bone with different substances. I'm gonna revise it once again. Okay, spongy bone, it is found in flat bones and epiphysis of long bones. Long bone, the part epiphysis contains red bone marrow and the type of bone present in epiphysis is spongy bone. Spongy bone contains cells and matrix same as compact bone, but the arrangement of these cells and cells on matrix is different. The cells present are osteoblast, osteocytes and osteoclasts, and the matrix present contains two portions, inorganic portion and organic portion, same as compact bone, where the inorganic portion contains calcium phosphate and calcium carbonate, which together forms hydroxyapatite that provides hardness to your bone, while the organic portion contains matrix protein osin and the fibers present in the bone. But the arrangement is different. If you look at spongy bone, it is highly branched, and these branches are known as trabeculae. The empty spaces in between these branches or trabeculae is filled with red bone marrow. Since it gives off an appearance of a sponge, it is known as spongy bone. Now let's look at treatment of bone. When a bone is treated with HCl, the inorganic part gets dissolved. That is, hydroxyapatite gets dissolved. That is, the bone loses its hardness. That is, the bone becomes flexible. That is, the calcium part has been removed. That is, the bone has been decalcified. That is, the process is decalcification. That is, the end result is decalcified bone. Second, treatment with KOH solution. There's no effect. It doesn't affect bone in any way. Third, treatment with heat. When a bone is heated, the organic portion is removed. The organic portion gets dissolved. As a result, the bone becomes brittle due to high percentage of inorganic matter. When you get older, the bone becomes more brittle due to decrease in percentage of organic matter. And when you are young, your bone is tougher due to the presence of higher percentage of organic matter.